Next, we're going to talk about what to do if your leading coefficient is not 1. So I'm going to come back to the original theorem that we had, the rational zero theorem. We have some function of x. You want to take the coefficient of your leading term. So whatever term has the highest exponent, take that coefficient, factor it. Whatever your last term is, the constant term, take the coefficient and factor it. And you are going to write a ratio as your last term or a factor of your last term to a factor of your first term. So coming to this example, we have 9x to the 4th power plus 3x to the 3rd minus 30x squared plus 6x plus 12. We are going to come up with a big list because 9 has several factors and 12 has several factors. All of these can be written as positive or negative. I think it's helpful to just pick the first factor pair for the denominator, or the first factor, and then write everything over that number. It's always 1, so you always just list off the first factor you could have, or the first list of factors. Then move to the next factor in the denominator and write every number from the first list over that second number. So we have positive or negative 1 over 3, positive or negative 2 over 3. 3 divided by 3 makes 1. That's already on our list. So we're going to write plus or minus 4 over 3. 6 over 3 is the same as 2. 12 over 3 is the same as 4, and those numbers are already on our list. So then the last number that we need to look at in the denominator is 9. And write all of those numbers over 9 unless it's a number we already have. So we have plus or minus 1 over 9, plus or minus 2 over 9, 3 over 9 is the same as 1/3, and that's already showing up on our list, plus or minus 4 over 9, 6 over 9 is the same as 2/3, which is already on our list, and then 12 over 9 is the same as 4/3, which is also already on our list. So we've listed out the possible zeros. Now let's check to see which one could possibly be a solution, or where some possible solutions are. We're going to go ahead and graph this equation. I already typed this in on my calculator, so if you need to pause and do the same, go for it. I'm going to hit the graph button, and I can see that -2 is a 0 because my graph crosses the x-axis at -2, and it looks like 1 is a 0 because my graph looks like it's crossing the line at 1. We can check. Let's try 1 as our first 0. And if you feel more comfortable with -2 because it shows up a little bit more clearly, go for it. I'm going to write out all of our coefficients. And use synthetic division. So carry down, multiply, bring back up, add, multiply, bring back up. Keep going until we get to our last term. And it looks like we have a remainder of 0, which is great. That tells us that yes, 1 is a 0. We also said 2 or -2 looked like a good option. Let's try dividing this entire thing now by -2. Carry down the 9. -2 times 9 is -18. add the 12 and the negative 18, multiply negative 2 and negative 6, and then carry back up. Negative 18 and 12 again, negative 6. Multiply negative 2 times negative 6, we should get 12. Add, we should be left with a remainder of 0. So yes, x equals negative 2 is in fact a second 0. For the rest of those zeros that we saw on that graph, I couldn't really tell where any of them were. So at this point, it's a good idea to either factor or use the quadratic formula. So let's try factoring first, because if you can factor, that tends to make it a little bit easier. One thing that I can see is that we can factor a 3 out of all these terms. If you can reduce it a little bit, make your life just a little simpler. That should be a 2. When you factor out a constant term, you always end up dividing it by 0, so it always ends up going away. This specific equation doesn't factor because 3 times negative 2 is negative 6, and the only factors for negative 6 would be 1 and 6 and 2 and 3. We can change the sign any way we want, it doesn't matter. None of them will equal negative 2. So we do have to use the quadratic equation for this one. And then plug it in. We can simplify. And then this would become 4 plus or minus square root of 28 over 6. 28 is not a perfect square, but it does contain a perfect square factor. You can list everything out, but if you can already see or you already know ahead of time that the pair is 4 and 7, you don't need to do all of that work. And I somehow wrote 4 instead of 2. Do not do that. That should just be positive 2 because the double negatives cancel. We get 2 plus or minus 2 square root 7 over 6. Okay, and if you're wondering why that didn't show up in our original list, be careful, the theorem says that it is the rational zero theorem. 2 plus or minus 2 square root 7 over 6 is not a rational number, so that's why it didn't show up on our list. That theorem only applies when we can write our answer as a fraction or as an integer. Okay, let's look at another example. Our next equation, we're finding all the zeros of f of x equals 6x to the 4th power plus 5x to the 3rd minus 39x squared plus 4x plus 12. Step 1 is always the same. You always have to list out all of your possible rational zeros. So you have to factor out the number 12, and you have to factor out the number 6, and we're going to write our ratios as the factors of 12 over the factors of 6. But we have all the factors written out. Again, I always like to start with 1 in the denominator, which basically means you just write out the factors of, for us, 12. Could be positive or negative 1, positive or negative 2, 3, 4, or 6, or 12. Next, we're going to write a fraction and have 2 be in every denominator. So positive or negative 1 over 2. Positive or negative 2 over 2, which is 1, and we already have it. Positive or negative 3 over 2. Positive or negative 4 over 2 is the same as 2. 6 over 2 is the same as 3. 12 over 2 is the same as 6, and we already have all those options. So let's write everything over the number 3 this time. Positive or negative 1/3. Positive or negative 2/3. We already have 3 over 3 because that's 1. 4/3. 6 over 3 is the same as 2. 12 over 3 is the same as 4. So the last fraction we would have to write is everything over the number 6. So 1 over 6. 2 over 6 is 2/3, or 1/3, and that's already on there. 3 over 6 is 1/2, already on there. 4 over 6 is 2/3, already on there. 6 over 6 is 1, and 12 over 6 is 2. So this concludes our list. Grab the graphing calculator, check for possible rational zeros. Our function is written right here. We have a few good guesses, or a couple of them. I can see -3 looks like it's a good guess, and then I can see that +2 looks like it's a pretty good guess. So we get to pick one, we get to check. I'm going to pick -3, but whichever one you want to pick it doesn't matter. We're going to use synthetic division. Carry up and multiply. This is a sloppy 5, but a 5. Multiply -3 and -13. Multiply 0 and -3. And then for -3 is -12. And a remainder of 0. We also said that 2 looked like a good choice. So now let's try dividing what's left over by 2 using synthetic division. Multiply the 2 and the 6, add the -13 and the 12. Always carry up and to the right. And we have a remainder of 0. So we didn't really have any other good choices as far as I can look and I can see exactly what the number is. So far we have x equals -3, x equals 2. Let's try and see if we can factor. 6x squared minus x minus 2 equals 0. This one does factor. Up above we have the number 12 already all factored out because 6 times -2 is -12. We can use the factor pair 3 and -4 to make -x. If you don't like the box method, you can use the quadratic formula. Factor out. That should be -12 right there. Everything out, we are left with the pairs 3x minus 4 times 2x plus 3. Set both equal to 0 and solve. Steps to solve are shown right here, but we're left with 4/3 and then 3 over 2. And if you look back up at our original list, all of these values showed up. All right, that is all for this section. Good luck and let us know if you have any questions.